nothing but address resolution protocol. And if I'll say to you that why we use it, so this protocol we use just for conversion of the or not the conversion, we can say the getting the MAC address. Getting the MAC address of the target device. And sometimes we also say that conversion from IP to MAC addresses. And the reverse of this process we call RARP. So reverse ARP, and by this we can say that IP to MAC, यहाँ लिख देता हूँ मैं. Okay, so it is nothing but MAC to IP address, something like this. So this is the basic story. Now we will see what is the requirement of this protocol and how it works. So I'm setting up one simple, very simple scenario. Let's say we are having a local computer, let's say this, or I'm calling it source. And there is a switch also, network switch. Okay, and by this the frames or the packets are transmitted, and at the receiving side I'm using it might be a server or a simple system, whatever it is. So I'm using a switch here. After this whatever the setup we will discuss, उसमें मैं router भी use करूँगा. So first I would like to ask you that what is the difference between switch and router? Both works, both the devices are used for the almost the same purposes, but still there is a difference between switch and router.
सर स्विच मतलब हर एक पोर्ट पे जो भी डेटा आ रहा है वो फॉरवर्ड कर देता है.
ठीक है. अच्छा देखो
राउटर,
ठीक है.
एंड राउटर मतलब जो स्पेसिफिक जिसको भेजना है उसी को भेज देता है वो.
ओके, इसको ऐसे भी समझ सकते हैं दैट राउटर इज हैविंग नंबर ऑफ स्विचेस. ओके, राउटर से बहुत सारे स्विचेस कनेक्ट भी होते हैं, और एक और इसका बेसिक वो है समझने का कि राउटर जो है वो डिफरेंट नेटवर्क्स के को भी कनेक्ट कर सकता है. ये सबनेट 1 है लेट्स से, और भी इसको सबनेट भी मत बोलो, नेटवर्क ए, let's say this is network B, this is network C, this is network D, and within the network what is the device that we use? It is called switch. Or the other difference is that we can say that router transmits the data packets and switches we use the frames, but but वो भी data packet ही होते हैं, but एक तरीके से technically आप बोल सकते हैं. So this is the basic difference. Okay, back to the main concern, that this is kind of the scenario, and first this switch, source will try to connect with this network switch and then to the target. Now this source is having its IP address. So इसका खुद का तो IP address इसको पता ही है, और MAC address भी इसको पता है, source. And source may have the IP address of this target device. It is the possible case, but the MAC address of target is not known by this particular source. And both addresses are required for establishing any kind of the communication. So this is the very essential task. And whenever we will say that Ethernet address or the MAC address, it is the notation of defining this address is the hexadecimal notation, and it is used something like this. Okay, मैं कुछ number ही use कर लेता हूँ. So it is like 12 say dot AFEC colon, let's say 4A colon 35 colon B1. So this is the standard notation and standard way of defining the MAC address in hexadecimal case, hexadecimal notation, hexadecimal notation. तो आप यहां से इजीली देख सकते हो 1 2 3 4 5 6 7 8 9 10 11 12 characters are there, or we can say 6 fields. Okay, और field से यहाँ मतलब है bytes से, 6 bytes are there. So overall this MAC address is related to the 48 bits length address. So this is the standard notation of MAC address, but ये source के पास MAC address नहीं है अभी इस machine का. MAC address will be defined at the time of the manufacture, at the time of the manufacturing process. So whatever the IC and IC whatever, तो वो predefined हो जाता है, पहले से ही fix हो जाता है. अब जब तक इस source के पास ये MAC address नहीं होगा, communication establish नहीं हो सकता. For getting this kind of the MAC address, we use ARP, Address Resolution Protocol. Okay, so now I'm moving to the next page. Now I'm exactly considering the scenario. So here a kind of the local system or the computer local system. Okay, then this is directly connected to the switch first. Okay, so this is network switch, and this switch is connected somehow to the router itself. Okay, now if I'm talking about a particular network, तो ये जो router है ये क्या हो सकता है? This router is nothing but the default gateway. Default gateway. Default gateway, and then it will be connected to the DNS server, or sometimes directly we can make the internet word after this default gateway. So it depends. And now I'm connected this. I'm making this internet word. Okay. So this router here, I'm considering the router like default gateway, because you know very well in any kind of the network, all the requests of the network will be passed through the default gateway to the word of internet. Directly system se nahi jata. Okay. So this kind of the scenario is there, and ARP request will be sent by local system to the router gateway. Okay, so in our case, the source, this is the source, and not in our case, this is general methodology or basic working principle, and this is the destination. Now, source and destination for what? For the ARP request packet. So this is the destination, and after getting the MAC address, जो भी अभी हमने डिस्कस किया था ये सिंपल. सो यहाँ सोर्स एंड टारगेट. So source is nothing but the local system by which we are trying to send the packet, request packet ARP, to the destination or the default gateway first, because after that that default gateway will handle each and everything for sending the data packets or requests for different purposes to the through the word of internet. Okay, and here I'm not going in detail regarding DHCP and DNS server, UDP, frame and all, because all are required, all are used for designing the request, the technical request to the system at the source side. DHCP is what? बताएगा कोई? DHCP is what?
DHCP राउटर पे नहीं होना चाहिए.
नहीं राउटर पे तो देखो, राउटर पर तो होगा. मैं आई एम सिंपली सेइंग दैट DHCP DNS, देखो ऐसे तो DNS सर्वर मैंने कहाँ रखा है? यहाँ रखा है ना. बट आई एम writing DNS server here also. I am just telling to you that with the help of these protocols, okay, we try to generate a kind of the request that will be understood to the system. पहले हम understandable request तो generate कर पाए. For example देखो, suppose www.google.com, okay, अब सिस्टम तो नहीं समझेगा ना google.com का मीनिंग क्या है. अब इसके आईपी एड्रेस को फेच करने के लिए या करस्पॉन्डिंग आईपी एड्रेस के लिए आप किसका यूज करते हैं, किस प्रोटोकॉल का यूज करते हैं? DNS एग्जैक्टली. तो मेरा कहने का मतलब सिर्फ यही है कि these are the protocols or the services that we will use for designing a understandable request. Okay, so DHCP is what? Dynamic Host Configure Protocol. ठीक, ये इसका मतलब ये एरो बना दिया. अच्छा, इससे शायद कंफ्यूज हो रहे हो यार. लो, इस एरो को मैं यहाँ से हटा देता हूँ. So these are the protocols that we will use. Now after this I am moving towards the ARP protocol structure. How many fields are there and how the ARP request works. Okay, so something like this. In the starting, the first field is the hardware type. Okay, then the next field is protocol type. अच्छा, इसमें थोड़ा सा स्पेस रखते हैं, जरूरत पड़ेगा. Protocol type. Okay, so 0 bit, now here 16 and 31. ये बिट लेंथ लिख दिया मैंने, एक रफली आइडिया मिल जाएगा कि each field is related to how many bits. Okay, in the next, the first part is the hardware length, or I am simply writing HLAN. HLAN, and the other is the protocol length. So PLAN भी लिख सकते हैं, but चलो ठीक है, protocol length like this. And the next field is operation. Then after this, the sender hardware address. This complete sender hardware address, or in short EAS. Now after this, the another field is sender protocol address. Okay, or in short IPS. The अब मैं शॉर्ट में ही लिख रहा हूं, it is nothing but हार्डवेयर एड्रेस और ईथरनेट एड्रेस ऑफ द रिसीवर, ठीक है। और इसको आप टारगेट, चलो लिख दो टारगेट एड्रेस। अब ईथरनेट है तो ऑब्वियस है कि ये हार्डवेयर एड्रेस ही होगा। एंड द लास्ट फील्ड इज IPR, मींस टारगेट प्रोटोकॉल एड्रेस or IP address. Okay, so this is the complete ARP पैकेट कह सकते हो, और रिक्वेस्ट पैकेट, और बोल सकते हो इसको। one by one we will talk about the different field. Now this is hardware type. So what kind of the hardware that we are using? So in each book and everywhere you will get that for the Ethernet, for Ethernet kind of the thing, we use field 1. So this is set to 1, and it is indicating that Ethernet kind of the hardware we are going to use. Now this protocol type field, so this will be filled with the hexadecimal notation, and for 0, 800, and this shows that IPv4. So IP version 4 is using here. Okay, now this is the H length, hardware length. So hardware length is fixed for the 6. So 6 is representing that hardware length, and as I told you that length of the physical or the MAC address is having the 12 bytes or the 12 fields, sorry 6 fields, but 12 characters, sorry 12 characters are there. अभी देखा था हमने तो, or we can say the 6 bytes, or we can say the 48 bits, total number of 48 bit length. Now similarly protocol length, so this protocol length, if it is set to 4, so now you can easily understand the 4 is set here, then it means IPv4 kind of the thing we are using, because in IPv4 you know the decimal notation, and according to this we are having the bit total number of bits are there. कितना होती हैं बिट्स? जैसे इसमें 6 बाइट्स था तो 48 बिट्स हुआ, इसमें कितना होगा आईपी एड्रेस के नोटेशन के अकॉर्डिंग? अरे ईच फील्ड 4 फील्ड में लिखा जाता है ना, 4 बाइट्स आर देयर ना, तो 8 पढ़ना यार अब इतना 32, हाँ तो 32 ना, तो ठीक है। ओके, नाउ ऑपरेशन फील्ड, and this field is having 1/2. Now 1 we use for the request and 2 is used for, ऐसे कर लो इसको, डिफरेंट कलर से कर लेते हैं, let's say black. 1 for the request and 2 for the reply. When operation field is set to 2, it means the ARP reply packet is transmitting from the target to the source, and if 1 is set, then it means ARP request packet is going to transmit uh, from the source to target. Okay, now all our fields are related to the sender hardware, means Ethernet address of the sender. Now this is the Ethernet, this is the IP address of the sender. Then similarly, Ethernet and IP addresses of target sites. So this is the basic protocol ARP structure, but ये directly इस तरीके से send नहीं किया जाएगा. For sending this, we require a kind of the Ethernet frame. Ethernet frame. Okay. So this frame is also having अच्छा एक उस प्रीवियस में हम ये भी चेक कर सकते हैं जो टारगेट हार्डवेयर एड्रेस होता है this in the starting target hardware address. So this is set to, in the initial case, 0:00:1 2 3 4 5 6. Because of the hexadecimal notations, so we initialize with this because अभी तो कुछ पता नहीं ना इसलिए. Now in Ethernet frame we are having the strict structure of this Ethernet frame. Now something like this. So first we are having the source MAC address of source, then destination MAC, and this destination MAC, this address is written here something like this: FF:FF:FF, then again :FF 1 2 3 4 5 6. Okay, now tell me one thing. In the structure we have seen that what is the ARP request. अभी तक ARP request का पैकेट का भी डिस्कस नहीं किया है. कोई बता सकता है ये जो एड्रेस लिखा गया है ये why we are writing such kind of the address here in the initial phase? Yes, definitely. So this is the broadcast address. Okay, so already we apply the broadcast address here, then type. Okay, so next field of this Ethernet frame is defining with the field of type, and this type is fixed 0 cross, let's say 0806. Now this is showing that this frame is related to the ARP request or the related to the ARP module. अब मैं request नहीं लिख रहा हूँ because request और reply दोनों के लिए frame use होता है. So for the ARP purpose, and then we are having the ARP request packet here. ARP request packet. Now this field is having the complete data we can see the data carried by this field, and ये जो back previously हमने ये जो protocol देखा था, now each and everything is inserted here in this phase, this ARP request packet, and at the end FCS field is there, checksum field, just for checksum for controlling the error things of the related to the different bits. That's why. So this is the Ethernet frame that will be designed, and this frame is having this ARP request packet जो अभी previously हमने discuss किया, और फिर इसको ट्रांसमिट किया जाता है इस फ्रेम को, ना कि सिर्फ इस रिक्वेस्ट हार्डवेयर जो भी डिस्कस जो प्रोटोकॉल स्ट्रक्चर देखा था सिर्फ उसको नहीं, बट अकॉर्डिंग टू द ईथरनेट फ्रेम. ओके, सो एज यू कैन सी दैट destination MAC is the broadcast address, so we can make a simple comment. One comment is that ARP request is the broadcast case, while ARP reply will be unicast. अच्छा, ब्रॉडकास्ट, यूनिकास्ट एंड मल्टीकास्ट, कोई बताएगा इन तीनों का क्या मतलब है?
सर ब्रॉडकास्ट हो गया कि आप सबको भेज रहे हो, यूनिकास्ट हो गया कि 1 to 1 जा रहा है, मल्टीकास्ट हो गया कि आप एक टू फ्यू भेज रहे हो, मतलब सिलेक्टेड वंस भेज रहे हो. ठीक है,
ठीक है, तो अब इसको टेक्निकली अरेंज कर लेते हैं. ब्रॉडकास्ट मीन सिंगल ट्रांसमीटर ऑल द रिसीवर ऑफ द नेटवर्क. यूनिकास्ट सिंगल ट्रांसमीटर सिंगल रिसीवर. मल्टीकास्ट single transmitter and more than one receiver but not all into the network. Okay, so this is the unicast thing, reply, ARP reply. Okay, now we will see that how this frame will work और कैसे जाता है. तो हम वापस से यहाँ पर डिवाइस बना लेते हैं. This is local system. Okay, now this is connected with the switch, network switch. This is somehow connected to the router, and now you know very well what is the meaning of router, gateway kind of the thing. Then a DNS and the outer world, DNS and the internet. Okay, so with the help of physical layer, now physical layer handles for transmitting the Ethernet frame through the physical medium. So Ethernet frame, EF लिख दिया है मैंने. Ethernet frame will be transmitted via any physical link, this one, and this process will be handled by the physical layer of the OSI model or the TCP model, whatever. Now this Ethernet frame, यहाँ पर कई सारे devices connect हो सकते हैं. Device A, device B, let's say device C, now device D. Okay, so this Ethernet frame will go to the each device. ये frame सभी के पास जाएगा, ठीक है? That's why we are calling it broadcast. And after this, whatever the device wants to get the MAC address of router, now it will send or it will try to reach to the ARP request to the router or the destination. ठीक है? Now just wait. Okay, now here a kind of the checking will be done. Kind of the checking. As you can see that in the previous hardware type, the IP address of both IP address of sender as well as target, the hardware address of the sender as well as the receiver, both are there. So this router will check that the ये जो request packet आया है, it is having the correct IP address of router or not, plus the correct MAC address also will be checked. किसका? इस डिवाइस का, क्योंकि यहां पर एक टेबल मेंटेन होती है, इट इज कॉल्ड ARP टेबल और द कैश, ARP कैश। ठीक है। सो IP एड्रेस ऑफ रिसीवर एंड ईथरनेट एड्रेस ऑफ दिस रिसीवर। ठीक है, तो ईथरनेट एड्रेस तो अभी है नहीं, तो ये चेक करेगा IP एड्रेस। नाउ क्योंकि अब ये सेंडर हो गया है और ये रिसीवर बन गया है उस टाइम के लिए, या उसका अपोजिट भी कह सकते हो। वंस इट इज this process will be done, then this router will send the ARP reply. Now this reply, whenever ARP reply is there, so in the field of operation, so in operation field 2 will be set. यहां देख सकते हो आप, this I'm talking about this, 2 will be set, and because this is unicast in a manner, in this manner, तो ये वापस से यहाँ जाएगा और इस स्विच के थ्रू जिसका एड्रेस जिसने भी रिक्वेस्ट किया था सिर्फ उसके पास, लेट्स से डी ने किया था, उसके पास ईथरनेट एड्रेस चला जाएगा। सो दिस काइंड ऑफ द प्रोसेस will be handled with the help of ARP protocol, and this is the basic thing related to the ARP. Although there are lots of things for studying in related to ARP, फिर हम ARP भी पढ़ सकते हैं, but this is the basic thing. Source MAC रहता है इस फ्रेम में, और ये ध्यान रखना कभी भी ये alone we will not pass the ARP request. There must be an Ethernet frame that is having the separate fields, and each field is having kind of the different working principles. So with this we can have the access of MAC address of the the targeted device. Okay, now I am moving back to the slide also, so just wait. ये slide visible है अभी?
Yes sir.
ठीक है, okay, thank you. Okay, just wait. Okay, now here you can see that ARP is address resolution protocol. So a computer connected to an IP Ethernet has two addresses, we know very well. One is MAC address, it is unique one. Another is the IP address. We have talked about a lot of things for this. So IP communicates by constructing packets, it is also okay. Now packet are delivered by Ethernet. अब जो कुछ भी यहाँ डिस्कस अभी हमने डायग्राम में देखा था उसी को लिख रखा है, so there is no meaning of reading all the lines. Yeah, already it is written that packets into the frame, so always we deal with the frames, not the alone packets or the request packets. And when an Ethernet frame is constructed from an IP packet, it has no idea what the MAC address of the destination. Definitely, we are having the IP address, so it is okay, but it is very not difficult, but at the same moment, if we will not send the ARP request packet, so we will not have the knowledge about the MAC address of the targeted device, and all the things are there. So this is where ARP comes into the picture. Okay, so this is the general diagram, but personally I will not suggest to you that this is the okay diagram, that because this diagram suggests us that you will give the logical address to ARP kind of the input, and at the output we will get the physical address. But no, logical address vanish नहीं होता, वो रहता है, but हाँ हम उसकी मदद से physical address को कलेक्ट कर सकते हैं. तो somehow it is okay, but personally I will not feel that this is the exact one, but हाँ आप ऐसे कह सकते हैं that ARP is used for getting the MAC address, that's it. And the similar thing we can apply for the RARP also. Now this is the structure diagram, simple case that broadcasting, I'm looking for the physical address of a node, IP address दिया हुआ है, तो इस तरीके से जो अभी हमने किया आप देख सकते हो, request broadcasting way में है और reply unicast way में है. So kind of the thing is there. After this we have to discuss the, okay ये frame हमने discuss कर ही लिया यहाँ पर, so there is no meaning, ये लिखा हुआ है सारा कुछ यहाँ, ARP frame structure. Actually ये protocol structure होना चाहिए, frame structure इसको कहना इसलिए ठीक नहीं है क्योंकि ईथरनेट फ्रेम के अंदर हम एक फील्ड में इस पूरे को प्रोटोकॉल स्ट्रक्चर को यूज करते हैं, सो इट विल बी ओके. बट हाँ आप फ्रेम भी लिखते हैं, देन आपको कई बुक्स में फ्रेम लिखा हुआ भी मिल जाएगा, बट इट विल बी लाइक ARP रिक्वेस्ट प्रोटोकॉल स्ट्रक्चर. एंड दिस इज द एनकैप्सुलेशन. तो एनकैप्सुलेशन वर्ड इसलिए यूज किया जाता है, जो अभी मैंने आपको बताया, दैट दिस इज द ईथरनेट फ्रेम एंड दिस फ्रेम is having one field, this yellowish field is having all the data related to the ARP request or reply packet जो कि इस पर based है. So this is called encapsulation. So this is called the encapsulation of ARP request or reply packet into the data field of the Ethernet frame. Now frame word is okay here. CRC is using or other cyclic redundancy codes we will use for the error correction purposes. How ARP works, I am telling to you that related to the cache and the table. Sometimes we will have the already defined, आप चाहो तो command type करके देखोगे ARP space hyphen small a, then you will get the different IP addresses and MAC addresses of the devices. तो जो already stated है उसको वो static बोलेगा, और जो बाद में आप लिखना चाहते हैं, ऐड करना चाहते हैं, that will be the dynamical entry of the ARP table. So this is the case. There is no meaning of reading all the thing. How ARP functions we have discussed. This how ARP functions like this unicast manner. And after this we have to talk about the ARP poisoning now. So I personally feel that once you will go through whatever we have discussed today, and then suddenly we can start in the next lecture session regarding the ARP poisoning and the ARP attack, how, or we can even say it man in the middle attack for the ARP poisoning case. So now I am stopping the sharing and I'm done for today. Anyone is having any doubt? तो इसको पढ़ना देखना, ARP प्रोटोकॉल. कोमर का एक बुक आती है, डगलस ई कोमर, अगर मिलती है तो ठीक, अदरवाइज आप नेट पर भी अवेलेबल है, आप कैसे भी पढ़ सकते हो, इसको देखना. And then you will start with the ARP poisoning and the ARP attack in the next lecture session. Okay, any doubt? अच्छा हो या नहीं ये तो बता दो एटलीस्ट. अच्छा ठीक है. Okay, so thank you to all of you. Thank you.